Welcome. We are still on mechanics, and this is question number 4 of paper 1, which is momentum and impulse. So the recent question paper now in front of me was just saying, if you look at it, a tennis ball with a mass of 15.5 grams. Immediately you have to convert that to 2 kilograms. Just shift the comma 3 times, gives you 0. The mass will be 0.0155. That's the case. Then kilograms. We don't work with grams in paper 1, we are using kilograms. Strikes a stationary 8.45 kilogram block with a speed of 45 meters per second and bounce straight back with a speed of 10.6 meters per second. Remember, of these two velocities, one must be negative. We are dealing with vectors here. So if the to the right is positive, when it bounces off, it must be negative. That's about this. The block moves a distance of 1.32 meters to the right, as indicated in the diagram. Now, find 4.1. State the principle of conservation of linear momentum in weights. Now, one of the easiest principles is this one. Just say, in an isolated system. In an isolated system. When we isolate the system, the net external forces is 0. Net external forces here. External forces. Net external forces is 0. Equals to 0. So that's isolated. Now in an isolated system, the total linear momentum is conserved, remains constant, remains units the same, so no problem. As long as we talk about isolated system and the total momentum is conserved, that's very important there. Now 4.2, those are the keywords. Now 4.2.1, they are saying to us, calculate the magnitude of the velocity of the block immediately after collision. Calculate the velocity of this immediately after collision. Now we can use the principle here of conservation of momentum, because we stated it here. Remember, when you start in this case, say sigma pi equals to sigma pf. Very important to write that. Or some people can also go for this one. According to this one, they were separate before collision and they're still separate after collision. So 1,1i, 2,2i, 1,1f, 2,2f. So that's what you can do. And then from here now we substitute. Remember, no velocity, no momentum. Now when we look at the ball, we said the ball mass should be 0.0155 multiply, we take to the right as positive, multiply by 45, then plus the block was stationary, then equals to 0. Don't have to substitute there. And then after collision, 0.0155 was now moving at negative 10.60. Remember, we said if to the right is positive, to the left is negative, plus, and then the one that we are calculating now, the mass of the block is 8.45 kilogram multiplied by VF. If you use your calculator there, you will find the VF equals to 0.10 meters per second. You get 4 marks there, 1 mark for stating the principle, 1 mark for substitution on the left, 1 mark substitution on the right, or then 1 mark for the answer. 4.2.2, which is the last one in this case. They were saying to us, calculate the frictional magnitude of the frictional force between the block and the table if the blocks moves 1.32 meters before coming to rest. Now we can see we are given delta x and coming to rest. Initial velocity is the one that we calculated here. You see now if we've got initial and the final and delta x, we can calculate acceleration first. I think that's what we can do. Can use equations of motion, or we can even use equation of motion. I think will be the easiest one to deal with. We are given the initial is 0.10, final is 0, acceleration is the one I'm calculating, delta x is 1.32. Therefore the formula with this without time then will be vf squared equals to vi squared plus 2a delta x. Vf squared is 0 squared equals to 0.10 squared plus 2a multiplied by 1.32. So our acceleration will be negative anyway. A should be negative 0.00378 meters per second squared. Fine, then remember they need the frictional force. Now with acceleration we can find frictional force now, because we know the acceleration and mass can give us force. F net equals to ma. The only force acting on the object while it was slowing down is friction. Therefore the frictional force, which is kinetic, it will be the mass of the block, which is 8.45 multiplied by 0.00378 negative. Therefore the answer should be, in this case, negative 0.03, which is the same as 0.03 Newton. They wanted magnitude anyway. Fine, don't have to mention direction, and in brackets we know that it will be to the left. Fine, but we needed only magnitude. That is the last question in this case. That is for momentum. Please bear in mind, in case of momentum, know how to define momentum as a product of mass and velocity of an object. Mass of an object and its velocity, whereas impulse becomes the product of the net force and the time it takes while in contact or while acting. Whereas the issue of not in this question, elastic and inelastic collision, remember, just to put in shorts, elastic collision, sometimes you can be asked to prove. Then remember, in an elastic collision, both momentum and EK are conserved. Both are conserved. But in this case, it's only momentum that is conserved. But the EK is not conserved. Therefore, that is why if you want to prove that the collision was elastic or inelastic, you can use momentum. The difference will be with the kinetic energy. If the kinetic energy before is not the same as kinetic energy after, I mean that collision will be inelastic. So all real collisions are inelastic, and this one are imaginary collisions, so hypothetical ones to be precise. I think in a nutshell, that is a question of momentum and impulse. So very nice question, straightforward, no problem. Remember, no velocity, no momentum. That is the bottom line. And in all the cases, remember how to start. When you start, you must always know that now. You must always start, if you're going to use the principle, sigma pi equals to sigma pf. Very, very important, because we are using this one also to define the principle as well. So that's the easy to score good type of a question, momentum. Every learner can get more marks here. Until we meet in the next sessions, thank you. Bye.